I'm very happy to today sharing our video lecture that is on the importance of filters and frequency domain, which is one of the topic covers from the our standard syllabus, that is image processing. So here supposed to be understand the topic which we are understand and keeping on as a concept, which is the filters. How those filters are in the frequency domain also we are giving the understanding. So we are understanding such a concepts how we are filter is concentrated in the domain of frequency and how can we define it. So the concept of filter in frequency domain is same as concept of a mask in convolution. After converting an image to frequency domain, some filters are applied in filtering process to perform different kind of processing on an image. The processing including blurring an image, sharpening an image, etc., which we are going to be commonly proceed with certain filters named as ideal high pass filter, ideal low pass filter, Gaussian high pass filter, and Gaussian low pass filter. So based on these filters, which we are going to keep on to vary with the frequency components only. So that is, any image in a spatial domain can be represented in a frequency domain, but what do these frequencies actually mean? We will divide frequency components into two major components. Number one is high frequency component. Number two is you are going to understand low frequency component. The high frequency components which we can corresponding to the edges in an image. Low frequency components in an image corresponding to the smooth regions. That is a major difference. So, which we can understand such a frequency domain signals which we are going to be add together and getting sum of all the signals which we represent as one of the random signal in the frequency domain, which is we want to keep in the form of as idea of Fourier process. So, how it can be calculated in the sense, since we have seen in the frequency domain that in order to process an image in frequency domain, we need to first convert it frequency domain, and we have to take inverse of the output to convert it back into spatial domain. So that is why we are going to use both the Fourier series and Fourier transform in frequency domain, which has two formulas, one for conversion and one for converting back to spatial domain, that is time domain. So when we are going to concentrate such a filters which we are concentrating in the range of frequency, as we nothing but the low frequency image is simply a convolution of the original image within a 2D Gaussian filter. Whereas in the high frequency image is obtained by subtracting the low frequency convolution from the original image. That is, the high frequency image is shifted to account of for negative values result from the subtraction. So, we can define and classify the frequency domain filters. Number one, as we discussed in the earlier, how we are categorized into two, and based on those two categorization of the filters, we are going to extend it in terms of frequency domain filters, which are number one low pass filter, number two high pass filter, number three band pass filter. By the help of those classification, let me define what is the reason to classify those frequency filters in aspect of based on the combining spatial enhancement methods only. That is, the major objective is to enhance this image by sharpening it and by bringing out more than skeletal detail. That is, you are concentrating such a narrow dynamic range of the gray levels and high noise content image make this image. Okay, so that difficult to enhance strategy we will follow as by using the Laplacian to highlight finer detail, the gradient to enhance the prominent edges of the information. So, which we can understand in extendedly, the image which we are going to show is a nuclear whole body bone scan used to detect decrease such as a bone infection and tumor. So, for reasons that we will explain shortly, a smooth version of the gradient image we will use to mask the Laplacian image. So, finally, we will attempt to increase the dynamic range of your gray levels by using gray level transformation. So that is what we can understand such a theoretical information which we going to be apply here. The A image will be concentrating on image of whole body bone scan, and B is representation in terms of Laplacian, and A Laplacian of A. So and C is we represent in terms of sharpened image obtained by adding A and B, then you will get the D image. So this is C. So the combining spatial enhancement method, the goal enhance the image by sharpening it and by bringing out more of skeleton detail information. Coming to the filters and where we can apply here based on your selected filters of the value by using simple concept based on the comparison of pixel one to other. That is, neighborhood is defined as many as any area bigger than the single pixel, so maybe of any size or shape. Most used rectangular or round around the central pixel might be referred as to filters, kernels, templates, or windows. So, such a process, the result or response are of linear filtering with the filter mask at a point of x comma y in the image is r equal to w of your coefficients of the image, which we represent based on the your applied your what we call that one, which we are applying here in terms of filters, kernels, and templates or windows of process. Okay, so this is mask. This is your filters process, and mask start by one another. So smoothing linear filters mostly concentrating on as smooth in terms of linear spatial filter is simply the average of the pixels containing in the neighborhood of the filter mask. So these filters sometimes are called averaging filters or low pass filters only. If suppose average filter means you can understand the average value of total based on the your matrices value. So for example, you want to find such masks of size n equal to 3 and the masks of size is various n equal to 9 and 35 is the meaning of that you are going to be keep to compare original image in terms of enhancement method only. So the way we are concentrating such a filtering process is also extended in terms of ordered statistics filters or nonlinear spatial filters whose response is based on ordering in terms of the pixels contained in the image area encompassed by the filter, that is number one median filter for removal of salt and pepper noise, and max filter that is useful in finding the biggest points in an image. Min filter that is used for the opposite purpose, which we can understand by the help of some example is here, which we can apply in terms of order wise, order sorted wise, sorted. Then median filter of output is 20, maximum filter output will be 10, and the maximum filter output will be 100, which we are going to be connected from the values. That is the range of the filter which is going to be detected according to the median, maximum, minimum filters. So by the taking one of the example X-ray image of circuit board corrupted by salt and pepper noise, and from there we are going to be see the complete process from noise reduction with a 3 by 3 average mask, noise reduction with a 3 by 3 median filter. So by the comparison both, we can understand such a what we called, such a process of filter importance. Okay, you want to refer, you can also refer by using one of the textbook. So here another important point is the principal object of sharpening is to highlight fine detail in an image or to enhance detail that has been blurred either in error or as a natural effect of a particular method of image acquisition. Image blurring could be accomplished in the spatial domain by pixel averaging in a neighborhood. Since averaging is analogous to interrogation, it is logical to conclude that sharpening should be accomplished by spatial differentiation. The basic definition of first order derivation is the basic derivation of first order derivative of a one of the dimensional function is here is dou f by dou x equal to f of x plus 1 minus f of x. So with this, I want to conclude that though we are concentrated on the importance of the filter, which are concentrated towards to the application of enhancement of an image. For example, we have gone through the by taking X-ray board, that motherboard, and applied with some pepper and pepper noise based, and we applied average filter and median filter. The difference we found it, which is the best one. So which we concentrated such a process is completely based on the importance of the filters and it's in the frequency domain. Thank you so much for your concentration. We will continue the remaining things in next class. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.